Sure.
Okay.
So my name is Kristin, and I'm one of the electronics engineers here at littleBits.
And my name is Ed, and I'm also an electronics engineer. Kristin's been here for
About a year and a half. Yeah.
Been here for about 9 months.
And so, are you guys familiar with littleBits?
Yes, we are familiar with littleBits. I actually went to a gifted conference in Birmingham, and they kind of had them out and showed us what they did. So we have ordered some, but they haven't come in yet. We ordered a student kit, a cloud bit, and a mounting board. So they haven't really seen them in person, but they've seen videos, and they've been on the website, and they've seen, so they do know about them. We just haven't been able to play with them yet.
Well, that's great, and we have some different stuff like that. But I guess we're here to kind of talk about what it's like, not just to play or to work with littleBits, to actually make them, right? Because we're the engineers that figure out how everything should work together, and then also have to tell factories how to make them, and go kind of shopping for these parts around the world and find factories that make the parts that make littleBits and a bunch of different stuff.
Yeah, so I guess to start off, you guys, what do you think electronics engineers do, or what do you think engineers do in general?
Hi, my name is Kayla Romero. An electronic engineer is someone who designs and develops new electrical equipment and solves problem and tests equipment.
Well, all of those things that you do.
I think y'all were cutting out a little bit. It's probably on our end.
Yeah, that's a good answer. All of those things that you mentioned, we do here at littleBits. We design, we test, we build things. What you want to add?
Yeah, we also have to do those all those things in small groups or teams, right? So some of these projects we work on are simple enough that just one of us can kind of manage everything and get it all done in time. But we often have to work with 1 or 2 or 3 or even 8 other people together, and that involves kind of organizing how a really complicated project like a space shuttle would get cut up into hundreds of different jobs and tasks, and that's kind of one of the maybe more less interesting parts of engineering. But I think it's a really fun one actually, because we're always learning, and we're always learning from other people and sharing specialties and tricks and
so what happens? Because we do a lot of engineering STEM type challenges, and sometimes we don't always agree, and that sometimes we want to work independently instead of working in a group. And I kind of told them that the more minds there are, the better the creation you can come up with, and they don't understand that when they don't all agree, what do you do then?
So we have a lot of that here a little bit too. Everyone has their own opinion and is very, vocal about that, and it's great to have your own ideas. And that's what makes working in a team great, because you see ideas from all kinds of angles, and when that happens, we usually just have to compromise. We lay out all of the options, and we look at what works best. Sometimes parts of someone's idea will work better, but other parts from someone else's plan will work better with the in the whole design. So it's not that one person's whole idea is like taken into consideration, but everyone's is, and we usually group everyone's ideas together to find the best solution.
Yeah, I completely agree. Generally anytime there are conflicting ideas, the kind of two or similar ways that you want to approach the conflict is to separate yourself from your idea, because there's nothing personal. Where it's all about just trying to come up with the best way to do things. And often the best way to do things is not solely what you think and solely what someone else thinks. And so it's completely about compromise and a little bit of humility, you know, and willingness to be wrong, you know, because if you only give people ideas that you know are right, then you're going to miss out on a lot of really exciting ideas just because you don't know that they're right yet, or that you're not investigating. You know, brainstorming is really important, and brainstorming in a team is really important. Not being afraid to say something which might end up being wrong because you're all there working on something together.
Yeah, you know, and if you do have, you know, ideas and you're working in a team, it's better to just say them and, you know, talk about them, even though you think you're not too confident about them. Your other team members will hopefully, you know, talk them out with you, and you know, there's no shame in being wrong because we're wrong a lot of the times too.
Yeah.
So it takes a lot of figuring out, and that's part of the process when you're working in teams.
Great, thank you. It's hard to understand sometimes. Sometimes we just want to give up and we don't want to be wrong, and it's important to understand that working as a group, we can share ideas, and sometimes when we share ideas, we come up with better ideas. So that's great. So who has the question about the pieces and if you make them with your hands or with your hands? Okay.
Hello, my name is Kanan, and when y'all make littleBits, do y'all mass produce them or do you make them by hand?
Sure. Nice to meet you, Kaden. We do both, basically, right? So when we're designing it and we're coming up with like solving problems, we're building everything by hand. Like we make stuff. I'm very gently unhooking a prototype right now. Yeah.
So we make stuff like this.
Yeah.
It looks really messy right now.
Or things like this, right? And this is all built by hand, right? There's a lot of kind of craft that goes into electrical engineering, and it's almost like making jewelry, or like because it's a lot of soldering and like metal work and really small details. You know, we use tweezers basically all the time because a lot of the things we're dealing with are very, very small. But it's all working towards bringing an idea or a device to a place that it can be made by a factory. And this day and age, that means getting made by mostly machines. And so that understanding that process is a lot of what we do. Like understanding what the difference between someone soldering something by hand or making a circuit by hand and how a machine has to make a circuit. And how to do that quickly, and how to make sure, you know, that most of them work instead of half of them. So the answer is really both. You know, we spend most of our day, you know, writing code and building circuits by hand, but the end goal is so that they are mass produced.
Yeah, I just wanted to develop some of our products. You know, we start really hands-on. This is what's called a breadboard, and it's basically a piece of perforated board that you can solder components onto. And so we use either these or something like this, where you can put LEDs and switches and knobs. So we use this to kind of test out our designs and then figure out what works best. And then eventually, you know, they become something like this, which you see on our website. So the beginning stages is a lot by hand, but then eventually the modules like this are made in the factory.
Thank you.
Any questions?
Thank you for the answer.
Yeah, thanks for your question.
Hi, my name is Ella, and my question is, how are you sure that the little bits will work once they reach the person who ordered them?
Do you test them?
Do you test them before they leave, or?
Yeah, that's a good question. So, as Ed was saying, our stuff does go through the factory, and they're made in factories, and then put in boxes for the final kits to get sent to our customers. Before they're put in the boxes, they do get tested by people at the factories, and also this is what we use to test them. It looks really complicated, but basically just check the configuration and all the electrical connections of the little bits. So we try to make sure that each little bit that reaches the customer works great and is a-okay. But there are some that get through, so we do our best to make sure everything's working.
Yeah. But basically, yeah, we made a giant little bit that lives in the factory that can test everything that it's making, basically. But
yeah, thanks for the question.
Great. Thank you.
Hi, my name is and my question, do you have to use source codes for every little bit you make?
Sure. Not everyone. Some of them are completely what's called an analog design. And what that means is that basically there's no computer inside. It's just electronics. It doesn't run a program, right? It's not a computer, right?
It's just like, so an LED, I don't know if you guys can see this. An LED is an example of something that's just electronics, no computer inside.
But there's a lot of little bits that do have computers inside, like this one, and this is running source code that Kristin wrote, that controls the number display and listens to the input and controls what the output does, and so there's a lot of source code there, and it's running on an incredibly tiny computer called a microcontroller, which basically is the entire computer. It's got the hard drive, it's got the memory, it's got the CPU, all in one, all in this little tiny chip.
Yeah, so we have a few bits that are, that have source code that live inside them, but we're making more of those, and a lot of our little bits, our base library is all analog, so no computers inside.
Yeah, thank you for your question.
Great.
Hi, my name is Kinsley, and my question is, how do you get your ideas to build little bits?
So we have a whole team here at littleBits, and we're focused on making things that people like. So we talk a lot about ideas that come up and look at what's out there that we could try and make easier. So we basically, if anybody has any idea for new little bits, we kind of just talk about it and try and make it happen.
Yeah, and we also listen to people that use little bits really closely. Like we have a long list of dream bits. We also just started a program called the Bit Lab, which if you want to design your own little bit, we'll help. You submit it to us and you make a video, and it's more for people that are already engineers or teams of people even that have engineers and designers on them. But we're trying to get ideas from everybody. We're in the spirit of just there's no bad ideas. Put it all on the table, and that's really one of the most important things about good design of anything, whether it's clothes or I don't know, anything is to have a lot to work with. When your garden's full, you get to pick which tomato you eat, right? For lack of a better, you know.
So yeah, we have a whole bunch of ideas, and not each idea isn't necessarily made, but we pick the best ones out of those, and we make those. Here.
Thank you.
So where are you guys right now? Is this y'all's lab? Is this where you guys work?
Yeah, so we're right now in the engineering shop. So you can see sort of behind us, we have a whole workshop filled with components and parts and test equipment, soldering irons, you know, anything that we would need to build or test or design any of these modules. The shop's pretty big, so behind this kind of like divider, where we've got some other engineers over there, but we also have a process, I guess, to make prototypes. So the boards that you see on our website, you know, we have to test and test them a lot. So we make some prototypes of these, and then they go through a lot of testing here at our office.
Yeah, a lot of fun toys.
Awesome.
Hi, my name is Jensen C, and my question is, how long on average does it take to make one little bit?
Good question.
That depends on how complicated it is. Like making the cloud bit, it took our entire team probably a good 4 months. And that's one of the most complicated bits we had made. And I guess it's 6 people, or it was 6 people then? 6 of, so the most complicated would be like 6 people, 6 months. And that's not for the factory to start making them, that's for us to be able to to release it internally into the company. But a simple bit like this switch, I mean, something like this, even like a day. And most of that would be just documentation and formal testing and kind of writing down that yes, indeed, it's a switch, and yes, indeed, it switches. So,
Awesome.
thank you.
Hi, I'm Jonah. In your opinion, what's the coolest invention that you've seen made with littleBits?
That's probably a hard one.
So we do a lot of community projects. Check out our website project page. A lot of our community uploads their projects and uploads their inventions. One of the cooler ones I've seen is a picture replicator using the Lego brick adapter that we just released. So basically, it uses DC motor and some other little bits, and there you have a picture on one side. In the video, it's a picture of a dog, and it replicates the picture on the other side using a crayon. So if you haven't seen that video, you should definitely check it out. That one's great.
Yeah, that was mind-boggling. I mean, the big word for it would be that it's an electronic mimeograph. So it's basically like a weird copying machine. Yeah, that was really cool.
What about you? Have you seen any cool inventions on the project site yet?
Not really.
What was that?
Yeah. The Babbling robot was pretty cool.
Yeah, okay.
They liked that.
I also really like.
I'm sorry. We saw that we've kind of looked at Makey too, and we saw that you guys have that Makey the combo on there. So that interests them too. But they like that you can get on there and see, it shows the list of how it's done.
Hello?
Hello?
Are we there?
Yeah.
Yeah, a little bit, but you're there now.
Okay, we were just, we were looking on the website, and it's kind of like they have recipes on how you can make each one of those designs, and I guess you can buy the little pieces separately if you wanted to make each one of those projects. So they enjoyed watching those.
Yeah.
Thank you.
Yeah, we have a whole, thank you. Yeah, we also have a whole bunch, there's a bunch of community projects, but we also have a whole bunch of, a really awesome design team that they don't so much, we work as engineers with them to kind of choose very particular ways that the little bits work together to kind of enable a lot of those cool projects. And they do a lot of neat testing in-house, and their job is basically to do arts and crafts, which is, it's a lot of fun to be around and to work with them. You know, that's another big part of our job too, is working with industrial and media designers that take the little bits and you know, and do everything from help make the website to help curate projects or work with community members on projects that, you know, it's a neat thing.
So, I assume that you guys both have engineering degrees. How long does that take to get an engineering degree, and what exactly do you have to be interested in? Like, what made you guys, how did you guys get to work at littleBits?
So I went to electrical engineering. I kind of got interested in engineering because my older brother was an engineer, and I kind of saw what he did, and I liked taking things apart and trying to figure out how things worked. I remember, you know, my really old cell phone broke one time in high school, and I like broke it open to see what was inside because I knew I wasn't going to use it anymore. So I was like trying to figure out, you know, like what parts were in it and stuff like that. So I chose engineering because I saw my older brother do it, and I just thought that I might like it, and I went into it and I did. So I stuck with it. So I went to college. I went to a 5-year college because we did some internships where I worked at some other engineering companies during school. But yeah, so I went to college for 5 years and graduated, and then I moved to New York, and I found littleBits, and I thought what they were doing is awesome, and so that's how I ended up here.
Yeah. Yeah, I too went to college. And got an electrical engineering degree, and I knew that I wanted to do that. And it was mostly through taking stuff apart and being interested in how things are made and what parts were inside of things that were broken that I could reuse, or you know, like how could I replace the battery? You know, well, I came from being a musician actually, and I didn't go and get a college, get a degree in electrical engineering, and you know, and kind of late basically. I went back to school because I was really fascinated about all this stuff that was inside all of this musical gear that I was using. Turns out a lot of it is really easy to fix. Easy to modify, or when it's hard to modify, it's actually fascinating how you have to do that and what it takes. And so I was working as an electrical engineer after I graduated, mostly freelance, mostly actually just working for either theater or other musicians or artists, kind of making whatever they, you know, whatever they wanted. And I did some freelance work for littleBits, and we really hit it off. And I'm you know, I love what they were doing, and it's super fascinating. And so we hit it off, and here I am.
Awesome. You guys have time for some more questions, or?
Sure.
Yeah, a few more.
Okay. All right.
Hi, my name is Anna Marie. And my question is, where do you get all your little bit pieces to make the little bits?
I know you guys mentioned earlier that you guys get them from other companies, or we weren't really sure.
So there's like a whole for all of these little individual parts. There's dozens of companies that make exactly what you need. If you know some parts, there might only be 2 or 3 companies that make exactly what you need, but there's still this whole world where a lot of what we do once we've settled on a design is shopping. Can we get those? How can we get those? How long is it going to take? And a lot of for Kristin and I, a lot of that is phone calls or looking at websites or talking to distributors that might be warehousing these things or that have more information about how soon a resistor is going to get made or you know, it being just like one of the little parts on the little bit, you know. Yeah. So it's, you know, it's you can't make something with something with a part that doesn't exist yet. In fact, we call it vaporware. So that means it's made out of air, you know, instead of carbon. So, yeah.
Awesome. Well, thank you.
Thanks.
What was, I saw someone else back there. Addison, did you want to ask yours? Okay.
Hi, my name is Addison, and about how many kinds of little bits are there?
How many times?
Like the individual pieces, I guess they're.
About 50 or
That sounds about right.
So we have about 50 or so in the library, and they're all listed on the website. We're coming out with some new and cool little bits pretty soon. And I think Ed has a little demo with it,
yeah.
which we can show you one of our new little bits.
Yeah.
Yeah, so this one is going to be in a kit that's going to be released in about a month, I guess. And it's the first time that little bits. It's not really. Okay. But what it does is I'm actually sending a remote control signal to these lights. There we go. There they're going.
So he's holding a little bit circuit in his hand, and that's controlling the lights behind us. And so this is called the IR transmitter. Basically, it communicates with an IR signal, which is a type of wavelength. It's a type of light that you can't see. It's not visible to your eye, but it's actually communicating to a switch that's plugged in over there and turning the lamps on and off.
Yeah,
it's pretty cool.
It's like a remote control for like a TV or something like that. You know, how those work is they're like flashlights that send out information that blink on and off really quickly, basically. But it's all in light that you can't see. It's all invisible. Yeah, and you know, and to kind of get at the question like what are the types of little bits out there? Generally, we have things that we call outputs, like this motor here. You know, and so this outputs something that you could like a stick to, and then maybe it pushes a ball down the hill, and this, that. And then we have inputs like a temperature sensor or just a switch or a knob. And then we have, or like this here, like, and so if we slide this back, there we go. If I slide this back and forth, you'll see it'll slow down. And we have a lot of these, like a pressure sensor or the light sensor or the sound sensor. So
yeah, they kind of encompass a lot of things: sound, light, motion, and you can do a lot with you know, the 50 modules that are in our library right now. And we're always looking to make more. So that's definitely going to grow when the comments.
Yeah, we have a whole musical kit too. You know, that's like a synthesizer basically that's all geared to making music. You know, so there's a lot of different, things, you know, different types of little bits like that.
Thank you.
Thank you.
They're really curious about this question.
Hi, I'm Olivia. And does something like a little bit power something in your company building?
They're wondering if, like, you guys have little bit creations that control something in your building, like you guys just did with the lights. Like a little bit, like something that is controlled by little bits that y'all actually use, like a doorbell or.
Yeah, we have a doorbell. We also have a timer on a water cooler that we call Mr. Thirsty, so that we don't have to sit there and just hold down the button on the water cooler. We can just press the button once, and this little motor presses the button for us, and then it waits a certain amount of time, and then it releases the button so we can walk away from the cup of water.
We just set up a doorbell because we're coming out with a new module called the MP3 player. So I believe it uses the cloud bit.
I think so, yeah.
Anyway, it's a doorbell that you can use for one of our conference rooms. So, you know, we have that. Yeah, we kind of make, whenever we think of something that needs to be solved around the office, we try and figure it out and figure out how to solve it with little bits. So things come and go around here, but we use little bits to solve some problems, definitely.
Well, great.
Thank you.
Could you, did y'all want to share something with us? I didn't know she was. We were kind of wondering, we were trying to figure out more about what the cloud bit does. We saw that, I guess it connects any little bit to is it the internet? Is that how that works? But they're wondering how, like, that connects to Wi-Fi and, like, how the whole thing kind of, how you guys designed it to work like that. They just don't understand how they can't see it, you know, them talking. They don't understand how it works.
Okay. And
so
it's a little computer. Yeah, this is the cloud bit. And it's a little computer. It's got one input and one output. This is the CPU, right? This is the memory. This little SD card here is the hard drive. And we programmed it using source code to use this radio here, right? Radio is another type of invisible light. This is one of the things I am most in love with about electricity, radio. Because it's all invisible light. Our eyes are sensitive to, you know, red, green, blue, yellow, but outside of all of those colors, there's X-rays and microwaves and radio and the FM radio and you know, a whole spectrum of what's called electromagnetic radiation that we can't see, but we can still use, right? So this little radio is a Wi-Fi radio. That's what Wi-Fi is, or wireless internet is actually a little microwave radio, and so is your wireless router that you would plug into your internet connection. So what this does is we built a simple system where you can connect this to power. Flip it around, and this one works, right? So this light comes on, and if this one really works, and I'm not sure that it does because we just picked it up off the desk, the light will actually change color, and that means it's ready yep, there it goes. That means it's blinking, so that means it's ready for us to tell it using the internet to get on the internet. And so you go to a web page on the littleBits website, and you say, hey, I got a cloud bit. You know, I want to set it up. Oh, I'm forgetting a part. And then you hold down this button for, I disconnected it, so I have to wait for you. And so you hold down a button on the cloud bit, and then it enters a mode that says, please get me on the internet. And then you go to a littleBits web page, and you say, I've got a cloud bit that says, please get me on the internet. And then the littleBits web page will tell the cloud bit what the name and password of your Wi-Fi is. The same way that you have to sign on with a computer to a new wireless signal. And once you do that, the cloud bit will now automatically sign on to that wireless signal anytime it's around. So it's just like, it'll remember it. Like, you can, of course, go back and reset it. But once it's signed on, the cloud bit remembers and the littleBit web page remembers. So you can go to the web page and move a slider on a cloud bit, which is in Japan, and the signal that you're sending the cloud bit will come out of it. That also works the same way, where if you've got a cloud bit that you've set up and it's in India, and you put a temperature sensor or a switch on that cloud bit, you can go to that website, to the littleBits website, what's called Cloud Control, and you can see when that button is switched, or you can read the temperature in India. You can also hook two cloud bits up to one another, right? So you can have the cloud bit in India be sending the temperature through a cloud bit in your classroom out to a light, or a switch out to a light. So whenever that switch is pressed in the classroom next door, the light will be on in your classroom. That's how our doorbell works, right? So we have a cloud bit, which is on the internet, and a button. And so you go up to the door and you press the button, and it goes through the internet and talks to another cloud bit that's connected to a buzzer. And so that signal comes out. There's more things you can do. You can put a lot of programming in between and a bunch of different stuff, but automatic, instantly, you do it. Yeah, I don't know. Anything?
It's froze up a little bit. Can you guys hear us?
Detailed instructions for that. Maybe you're a little choppy. I don't know.
Yeah, it's kind of cutting in and out. But you just said there's detailed instructions on the website as well.
Yeah, it's really easy to follow if you go on the website. There's pictures, and click next when you're ready. So it's really easy to get the closet connected to the internet.
Yeah, and if there's something not working, you just call us. There's people here, you know, this hour and after, actually, who are who are ready to help you troubleshoot or walk through it and make sure that everything's okay. You know. But
Awesome.
so once you go through what's called a commission. Yeah, thanks. Yeah, it might be a little. So, are there time for any more questions or anything else?
You guys have any? They are wanting to know what the Bit Lab is.
Okay, so Ed mentioned it before, but the Bit Lab is for people who make their own little bit. So they have an idea, so you have an idea, and you want to see little bits make it. So what you do is you prototype your idea, submit it to us with like a video, and you if your design gets enough votes, then little bits can possibly make that for you and to sell. So it's for people who are a little bit more familiar with electronics, or maybe people who have idea and they find somebody who can make the electronics for them. But it's a way to get the community really involved in making little bits and adding to our library.
Oh yeah, and there's money too.
Yeah.
You get if the whole process goes through, you get 10%. The creator, the person who had the idea and made the prototype, gets 10. I think it's 10% of the sales for the life of it. So you could potentially make a fantastically popular, wildly successful bit and a significant amount of money from your invention. So that's part of the motivation of it, not just to make new bits, but because it's a fair amount of work to make a bit, even if it is fairly simple,
So I think we have time for maybe 2 more questions.
Yeah.
My name's Caroline, and I wanted to know how many Little Bits factories or offices are there?
I think so.
Can you hear us?
Yes, we can hear you now. Can you repeat that, please?
Yeah. So we have one main office here in New York. That's where Ed and I are sitting right now. And then we have, I believe, 2 factories in China that make our modules. And we also have another 3 that creates the connectors, the magnetic connectors that you see on the ends of the little bits. So I guess 3 factories in total.
AIA, and there's a factory in Pennsylvania too.
Yeah.
Thank you.
Thank you.
Hello, my name is Addison Loudon, and it's very nice to meet you. And my question is, how exactly do you connect little bits to electricity?
It's a good question.
Yeah, sure. So we have a bunch of different what are called power connectors, right? So this little glowing red dot, if I can get it close enough, is actually a USB. Right, so this uses like a little phone charger. Okay, a little phone charger. And it can be any phone charger, or it could come from a computer, or anything that you could plug a USB into, like a car, or anything that has a USB port, and then this will get power all the way from the power station, from the power plant.
So then we also have another power bit, which is the P1 power. This has like a barrel connection, and this connects to a 9-volt battery. So that's, I think, one of the most common ways that people use little bits is with a 9-volt battery. You can also connect this to something like a phone charger. It's a 9-volt adapter that plugs into your wall. So anything that has a jack that fits in here. And so that will also supply power to your little bit circuits.
Yeah.
Thanks.
Thank you. Nice to meet you.
Okay, my name is Jaden, and do you have like a USB bit that can like charge a phone?
We have a USB bit that will run little bits off of something that can provide power, but we don't have anything that'll put power into a phone.
Yeah, it's a good idea though.
Yeah, that's not.
We'll make note of it.
Yeah. 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 So maybe one more question.
You guys are gone. That wants to ask the question. We're going through questions that you guys haven't touched on yet.
Okay.
Hello, my name is Kanan, and how do you get all the pieces and little bits to stay together?
Sure. So some of the parts in the connector here are actually molded into the plastic, right? So there's 2 little magnets and 3 pieces of metal that are all made individually, and then they're pressed together. And then the plastic part is made in the plastic connector is made in, I think, 2 different parts. And then it's all assembled and pressed together and stays, right? But for the most part, all electronics, and it's been this case for 50, 60, 70, maybe 100, Still there?
Yes, we're there.
Okay, sorry, I cut up. Maybe even 100 years have been held together by what's called solder. And solder is metal that melts at a really low temperature. And because metal conducts electricity, there's all these different ways, like a breadboard or like a circuit board like this, or even just what's called point to point to point to point, where you just solder the parts together with this metal that only melts when you put what's called a soldering iron onto it, right? So it's liquid when it's melted, and then you put the 2 parts together real quick, and then you let it cool off, and it's rigid, and it'll hold together, right? So if you look at all the all the metal, what looks like metal here is mostly solder. It's mostly a mix of silver, tin, and chemicals that help it flow better, called resin. And then you could be a PhD scientist that studies because it's one of the backbones of making everything from your phone to your toaster to to anything. Yeah.
So when you get your littleBits kits, you can check the back of the circuit board, and anything that looks like metal is probably solder. So you'll see them a little bit better when you have them in your hands.
Yeah.
Thank you.
Yeah.
Yeah. Well, thank you guys so much.
Yeah, it was great. You know, it's great to have you and great to answer your questions.
Definitely. Thank you for your time.
Thank you.